Hello everyone, my name is Ayush Singh and now we are going to solve the third problem of Shastra Challenge 4 Contest A, that is the maximum sum of diagonals. The problem states that Vibhuti was living in Bhandup and was a very curious person and he likes to play with 2D arrays. One day, he came up with a very interesting problem and was not able to solve that problem. Vibhuti was trying to find the sum of the diagonal elements of the array and we have to help him to do so. We can see that the input format of this is we are given the test cases and we are giving the n and m, that is the size of the row and column of the 2D array and the elements of the 2D array. The test cases are from 1 to 1000. The element of the array is from -1000 to +1000. The size of the array, the size of the rows and columns is between 1 to 10 to the power 6. Now we can see the input format and help us to understand this problem. We can see that we had given a 2D array that is 1, 2, 3, 4, 5, 6, 7, 8, 9. We can notice that there are 5 diagonals in this. 3 is one diagonal, 2, 6 is the other diagonal, 1, 5, 9 is the other diagonal, 4, 8 is the other diagonal, and 7 is the last diagonal. Now we have to find the maximum sum of this. So the maximum sum in this we can see that is of the third diagonal, that is 1 plus 5, that is 6, and 6 plus 9, that is 15, and other is smaller than 15. So now let us see the approach of this problem. Okay, so we are given a matrix, 2D matrix, and we have to find the maximum sum of all the diagonals. Means we have to print the sum of the diagonals which is maximum. Suppose in the first diagonal the sum is 3, in the second diagonal the sum is 6 plus 2, 8, in the third diagonal the sum is 9 plus 5 plus 1, that is 15, in the fourth there is 8 plus 4, that is 12, and in the fifth diagonal it is 7. So the maximum comes out to be in the third diagonal, that is 1 plus 5 plus 9. So we have to print the diagonal number and the sum. So first we have to know that there are how many diagonals in this matrix. So the formula for that is D equal to m plus n minus 1. M and n are the rows and columns of this matrix. Suppose let us see in the 3 cross 3 matrix, m is 3 and n is 3. So 3 plus 3 minus 1, that is 5. So there are 5 diagonals, 1, 2, 3, 4 and 5 diagonals in this. On the other example, in the 3 cross 2 matrix, if we apply this formula m plus n minus 1, we get out to be it comes out to be 4. So there are 4 diagonals, 5, 1, 7, 3, 9 and 6. So in the solution we have to print the number of the diagonal and the maximum sum. In this the maximum sum will be 9 plus 3, that is 12, and the number is 3. So we can see that in this, suppose in the diagonal 1 minus 1, the value of I and j, so I minus j is always constant in a diagonal. We can notice this. In this we can see 1 or 2, so 1 minus 2 is equals to minus 1 and 2 minus 3 is also minus 1. So in this diagonal of 2 and 6, the difference between the I and j is constant. So we can change this formula to be m plus this constant I minus j plus I, so that we can store the maximum diagonal in this format. So till now we have understand that we have to take the sum of all diagonal elements and we have to print the maximum sum of the diagonal element in this matrix. So let us see the code of this problem. We can see that first we have taken the input of the row and column, the size of the row and column, that is n and m. After that the mx we have to compare something with something, like we have to compare the last maximum with the current maximum. That's why we have taken mx as int min. We have taken the d as an input because we have to also print the diagonal, the number of the diagonal. After that we had here created a 2D array to store the matrix. After that, we had created the vector to store the diagonal element. Here we had taken the input of the 2D array as C in mat of I of j, and after that we are iterating over the 2D array, and we are here in this line we are just increasing the value. Suppose I had explained you earlier that we are using m plus I minus j minus 1, so that we can include the value. We can take the sum of the values of the diagonal, and then we will compare it with the last sum, with the last maximum. And if the last maximum is smaller than the current one, then we will update this answer value with the into max, and we will also update the diagonal value as m plus I minus j for increasing the diagonal element. And after that we will print the number of diagonal, and after that the mx maximum value. Here we can see that after this we can run this code and see that it should be passing the test cases. Just a second. Yeah, it's passing the test cases. We will submit the code, and all the test cases are passed. So this is the answer, this is the solution of the Shastra challenge question number 3. Thank you very much. The source code for this question is available in Python, Java in the description below. If you find this video helpful, then please like and subscribe, and follow TCD Shastra Coding Club on Instagram. Thank you for watching.